There are two different ways we can do addition and subtraction with mixed numbers. One is we can work with the mixed numbers. So 12 and a sixth plus 8 and 2/3. In order to add two fractions, I need the same denominator. Well, the whole number part is not a problem. 12 plus 8 is 20. But then I'm going to have 1/6 plus 2/3. I need to get those both to have the same denominator. Common denominator between 6 and 3 will be 6. 6 is as I want it. To get the 3 to the 6, I need to multiply by a 2. To avoid changing the fraction, I need to multiply the numerator by 2. So I have 1/6 plus 4/6. That is 5/6. And so this one, not very hard, 20 and 5/6. Now the other way I can do this is I can convert to improper fractions. The drawback with mixed numbers would be if I had something like 7/6 here, and then I'd have to move back and change the mixed number. I can always convert a mixed number to an improper fraction. 6 times 12 is 72, plus 1, 73/6. Plus 8 and 2/3, 3 times 8 is 24, plus 2, 26. Now, I do need to have the same denominator to add or subtract fractions. I have to have like terms. Well, 6 and 3, this one would be missing the factor of 2. So I have 73/6 plus 52/6. Scratch off to the side, 73 and 52, 125. Check to be sure this is reduced. Well, factors of 6 are 2 and 3. 2 isn't a factor of 125, and 5 plus 2 is 7 plus 1 is 8. 3 is not a factor of 125, so I know this is reduced. Again, depending on what I am doing, the rational number may be the better form. The improper fraction is 125 over 6. But if I wanted to write it out as a mixed number, I can simply do my long division. 125 divided by 6. (20 and 5/6), exactly the same we had gotten the other way. Okay? So those are the two different ways you could add fractions. Well, subtraction is just addition of the opposite. We can subtract two fractions just as easily. If I had 12 and a sixth minus 8 and 2/3, well, as mixed numbers, I'd have 12 and a sixth minus 8 and 2/3. Problem here, when I deal with the fractional part, getting my common denominator, I'm going to have 12 and 1/6 minus 8 and 4/6. So taking 4 from 1 gets me into my negative numbers. Can't handle that. I'll need to borrow from the 12, drop it down to 11, and then bringing 1 whole over, I'm bringing over 6/6. So this is 11 and 7/6 minus 8 and 4/6. 7 minus 4, 3/6. 11 minus 8, 3. 3 and 3/6, which then reduces to 3 and 1/2. A lot of places I can make careless mistakes with that borrowing, in particular with the reducing. If I converted this to the improper fractions instead, there's a lot less chance I'll make careless mistakes. Same mixed numbers, so same improper fractions. 73/6 minus 26/3. I need to have the same denominator because I can only add or subtract like terms, so I need to have the same things. This one needs a 2. Put the 2 in on top as well. 73/6. 26 times 2, 52. 73 minus 52, keeping any scratch work off to the side. 21/6, and that reduces very nicely. 3 times 7, 3 times 2, 7/2, which is again generally going to be the preferred form algebraically, but which converts very easily to the mixed number 3.5 without much scratch work at all. Lot less chance for careless errors using the improper fractions than with the mixed numbers. With multiplication and division, there is no opportunity to use this as mixed numbers. The only way to do multiplication and division with mixed numbers is to convert them to improper fractions first. So again, I tend to think it works better to just convert all mixed numbers to improper fractions. So multiplying 2, well, I need to convert these to improper fractions. 5 times 4 is 20, plus 1, 21/5. Times 14 times 1 is 14, plus 1 is 15. So I have 21/5 times 15/14. Now, I can do cancellation, remembering what I'm canceling, but again, I see many students make mistakes with that, so that's why I encourage going back to the prime factorization. 21 is 3 times 7, 5 is prime. 15 is 3 times 5, 14 is 2 times 7. So I can see that I get to cancel out a 5/5, leaving behind the 1's. 7/7. Can't do anything with the 3's because they're both in the numerator, so nothing's going to cancel. And I'm going to end with 3 times 1 times 3 times 1, 3 times 3. 1 times 2 times 1, 2. 9/2. This is simplified. Often you will generally want to give the answer in the same form it was given. So here, 2 goes into 9 4 times with a remainder of 1, 4.5 is a mixed number. But you do need the mixed numbers if you're doing a word problem. Otherwise, the improper fraction should be just fine. 3 5/6 divided by 5 2/3. Well, I need to convert each of these to improper fractions first. 6 times 3 is 18. 18 plus 5 is 23. I am not going to try to do more than one step at a time because I will make careless errors. So I'm going to leave this for now as division. 3 times 5 is 15, plus 2 is 17. So I have 23/6 divided by 17/3. To divide two fractions, well, I don't divide, I only multiply. I keep the first the same, and to divide, I multiply by the reciprocal of the second. Multiply numerators, multiply denominators. 23 is prime, 3 is prime, 6 is 2 times 3, and 17 is prime. I can divide out one of those 3's. I have 23 over 2 times 17, 34. Because I'd had my prime factors here, I know that this is simplified. So, mixed numbers, convert to improper fractions first, and then handle just the way you would improper fractions.